Students, welcome to SOURAV Sir's classes. We are going to solve a few questions on real analysis. The question is, consider the map f defined by fxy is equal to 7x plus x to the power 4, 3x plus 4y plus y to the power 4. Then option A, f is discontinuous at 0, 0. Option B, f is continuous at 0, 0 and all directional derivative exists at 0, 0. Option C, f is differentiable at 0, 0 but the derivative df00 is not invertible. And option D, f is differentiable at 0, 0 but the derivative df0, is invertible. Now we have f is equal to f1, f2 where f1 is equal to 7x plus x to the power 4 and f2 is equal to 3x plus 4y plus y to the power 4. Now f1 and f2 both being polynomial functions are continuous and so does f. So f is continuous too. Therefore option A is incorrect. Now the partial derivatives at 0, 0 are del f1 del x is equal to 7 plus 4x cube, which is equal to 7. Del f1 del y is equal to 0. Del f2 del x is equal to 3 and del f2 del y is equal to 4 plus 4y cube, which is equal to 4. Notice that in both of these, since x is equal to 0 and y is equal to 0, these terms vanish away. So df00 is equal to 7034 and the determinant is equal to 28, which is not equal to 0. Thus it is differentiable and the derivative is invertible. So option D is correct, whereas option C is incorrect. And we also know that if a function f is differentiable at x, then the directional derivative exists. Along any vector v. Now since by option D f is differentiable, so its directional derivative exists at 0, 0. Thus option B is also correct. Therefore option B and option D are the only correct options.